This SOM solution could take 6 to 12 months off your development time. Today, I've teed up an interview with Virtium Embedded Artists to talk about a new system-on module with AI capabilities, but stay with me. They are not messing around. You've got the inferencing power of a DeepX DXM1 at your fingertips, which makes it a very strong contender on the market. Today, I'm going to ask them all about why they've branched into this space, what's special about their solution, how approachable it is for us engineers to use, and learn how it fits into a larger system. Anders, Dave, thank you so much for joining me today. I've got a question. You've got a new release. Tell the world, what is it?
Oh, we're really excited about it.
Whoa, hold there. Only 12% of you are subscribed. Do yourself a favor and subscribe for daily engineering content. All right, enjoy it.
We're releasing, Virtium and Embedded Artists are releasing a unique product to the marketplace. It's a new family of seamless compute modules that can help customers that are on the edge compute work their way towards an AI edge solution, which is really fitting an immediate need for a fast time to market type of solution.
So you say Virtium, that's the company you're from, Virtium. Now, I'm sure most engineers who be watching this knew you from your memory and storage solutions. What's going on here? Why are we getting into an AI-enabled SOM? Why the switch up?
Yeah, that's a great question. Actually, Virtium, to your point, well established in the marketplace, a 25-year plus heritage of providing specialty memory and storage solutions into an industrial market that is everything from networking and telco infrastructure to medical devices to kiosks to robotics. And our customers were really looking to try to take this long legacy of engineering and see if we could adapt that to some new products. And at the same time, we saw a real good opportunity to leverage the modular portfolio that we have in the past and move it into the SOM market. And we were very excited to start talking with Embedded Artists. They have a long heritage of being in the SOM market, a fantastic engineering reputation. And when we finished talking to them, it made sense to bring them into the family. So we acquired them last year, and now we have a wide portfolio of solutions of modular products, everything from memory and storage all the way through the compute and SOM market.
So the Virtium Embedded Artist family, it's really grown now that you've got these two companies coming together. But let me get back to the SOM. Why are we bothering to create it? It's quite a dense market at the moment. It's a real new one that a lot of people are flocking to. What is special about yours? And what is the biggest technical leap forward that you've got on this device?
Oh, that's a great question. I think you look at, you can't go anywhere today without people talking about how AI is going to impact their lives. And so you have a legacy of hardware platforms out there that are on the edge. And these companies are trying to figure out how to get AI into those platforms as quickly as possible. And so what we've done is we've taken a proven solution with the NXP processor. This is something well established and mature in the marketplace that they're probably using already because NXP is one of the leaders in the industry. And we're bringing into that same platform a DeepX AI accelerator chip that starts to offload the bandwidth so people can adopt the AI type of benefits in a very quick time to market, modular, seamless integration. So instead of them having to go off and try to understand how to bring AI technology into their platform, which might involve them having to reopen their hardware design, they can actually take and leverage a modular solution, which again emphasizes the time to market, the efficiency of engineering efforts. And for us, we think this is unique in the marketplace today. No one has really brought out that seamless module with both the microprocessor unit on it, as well as, or the application processor unit, as well as that AI accelerator chip. Anders, maybe you can add some as well.
Yeah, exactly. And I really want to emphasize also that there is a lot of engineering hours that goes into this. So we really provide a proven infrastructure for a company to start working. They will get up and running immediately. And on top of that, I would like to add also that the DeepX DX1 is a very power efficient neural network accelerator. It only consumes about 5 watts peak, and while delivering 25 TOPS. So you really can run your system at a lower power consumption, meaning lower temperature, which equals longer lifetime and better reliability and so on. So there is a lot of technical detail that has gone into this design that our customers can benefit from.
Anders, you and I are both engineers, and we know that picking up a new platform, a new system on module is difficult. So I'm assuming that your company's done a very good job at making this something that is approachable. That's what's so important for someone who's looking at starting a new design, the approachability of the platform. So what are you going to provide them? You got code examples to use this, SDKs, BSPs. What have you got for us engineers who are going to be starting out with your product?
Yes, and yes. I completely agree with you. It's very important to have a low threshold of start using, and that has been the motto for our company from day one, actually. So, of course, we have a standard Linux distribution, a Yocto one, and there are SDK examples for the DeepX accelerator also. There is a big model zoo that you could choose from with a pre-compiled models that you can verify and evaluate very quickly. So yes, you get up and running immediately with this product.
So what is your SOM actually capable of? So we say pre-trained models, are these voice models, ones that can turn speech?
I mean, it is really focused on visuals, so video.
Visual, great.
The type of application that works best for this neural network accelerator are video applications.
If you think about it, there's a lot of devices sitting on the edge right now that are trying to get more out of their potential visual systems, the edge cameras that they want to put out there, particularly when you start getting into autonomous robots, industrial computing. Everybody's trying to determine not only how to use visual effects, but how to then use AI to help them make smarter decisions in their platforms. And so this processor is really strong from that perspective.
Great. And if it's good enough for video, it's definitely good enough for parallel sensors and fast data, fast reaction as well, correct?
Yeah, absolutely.
Absolutely. So we've just talked about how easy it is to use your product. Let's take a step back and think about how the engineer used to do it. So Anders, you've been in the industry for quite a while working as an engineer, and you've seen the times come and go in terms of technologies. What has this SOM taken inspiration from? And before this existed, how did engineers replicate its functionality? Was there any way to get this sort of intelligent processing without an AI chip or a SOM of your kind?
So, I mean, you could go for a very expensive NVIDIA solution, but that's just recently. If we go back 10 years or something like that, then this type of processing power wouldn't be available even. But I mean, if you would try to replicate this on yourself without using our product, you would have to buy an AI accelerator module, and you would have to integrate it with your design. A lot of hardware work. So this is just it. You speaking like saying like I did before. You are really up and running immediately when start using our products.
How much time do you suspect that engineers would save from using a SOM like yours rather than trying to reconstruct it themselves?
Between 6 months and 12 months.
So one of the biggest advantages of using a SOM like this really is the time that the engineer is going to save.
Yeah, you save time, and by doing that, you get to market faster, and that's really the big benefit. And you lower the development risk also. This is a proven platform. Remember that. You don't need to do any design iterations here. So, I mean, it is a standard SOM in the meaning that we have a gigabit Ethernet interface, we have optional Wi-Fi and Bluetooth module, and so on. And of course, the video input comes via cameras and so on. So it is a standard SOM with an AI accelerator.
Anders, you mentioned that you have versions that have optional Wi-Fi. So does this mean you've got more than one solution under the one umbrella?
Yeah, definitely. There are multiple product options there, and even mounting options. So we could fit this board with different amounts of RAM and flash and so on. We can have commercial or industrial temperature range with or without Wi-Fi option. We have one standard solution for the Wi-Fi that is Wi-Fi 6 solution, but we have a very strong relationship with Murata, for example, which is the world's largest supplier of Wi-Fi and Bluetooth modules. So we can mount any module that they have on this board, actually.
Great. So you've got a very capable solution here. Dave, what are some applications that you feel are going to be coming out of the hood on this one? What will engineers be using this for in time?
Yeah, I'll tell you, the applications that are really looking at this are people that have already established their brand and their products out in the marketplace right on the edge. So hardware platforms that are existing on the edge that need to bring some AI capabilities as soon as possible into their platform. So time to market is really key. The applications that are attracted to this are going to be your medical devices that are out there in the marketplace today. Anybody trying to use edge cameras and bring vision systems into their platform. Robotics, industrial computing, which includes factory automation. We're seeing a lot of interest in the kiosk marketplace, drones. There's a whole lot of devices sitting on the edge that are trying to bring up that AI intelligence as quickly as possible. And those are the target customers that are going to be interested in a solution like this.
Great. Are these the people that would be interested in low power or high performance? Where does your SOM sort of sit on that spectrum?
I think that low power is really important when you deploy things on the edge, because it's not always easy to cool thing or in general have a good heat management. So low power is important.
Yeah. So would you say that the engineer who's using this would be more looking for the low power solution or the high performance system?
So I think actually it depends on your application completely. The application will dictate a certain performance that's needed, and then it's the engineer's task or job to find a hardware platform that will implement that type of compute that you need at the lowest power level.
So say I get my hands on this, which I hope I do, and I fall in love with it. I want to buy 100 of them and implement them into the field. How am I going to go about scaling this? Is this something you've considered to make this a good product for real enterprise use?
Yeah, that's a great question. I think obviously when we're in production of the product, we're going to have the ability to scale to volume. And for those OEM customers that we engage with, I think it's important to note that we are actually a USA-based company with manufacturing also in the United States. So from a volume scalability standpoint, we're going to leverage our existing manufacturing facilities, and these products will be developed and built out of the US.
Great. So as we're recording this, we're currently in June 2025, which means tariffs. Does that mean our American audience can avoid the tariffs going with this product?
That's another great question, because we actually have 2 manufacturing locations. We do most of our primary manufacturing is based out of the US. We also have a manufacturing facility over in Vietnam. And so for customers today that are working with us on how to understand the impact of tariffs, giving the customers the flexibility to use both locations is becoming a very important feature for them and a very important obstacle for them to kind of work through.
Great. That was awesome to hear about. Dave, Anders, thanks so much for joining me today. Cheers.
Yeah, appreciate it. Thank you so much for your time.
If you're interested in getting your hands on the IMX8 Mini DXM1 SOM, we'll have an article in the description you can read for more information.